Good day everyone, I'm Carly Bonipata. In this video, I will be talking about laser surgery. So how did laser surgery come to dominate the world? Lasers are incredible tools that are fundamentally changed the world which we live in. But when they were first invented in 1960s, lasers are famously dubbed as a solution looking for a problem.
First, let's have the brief history of laser light. 1916. Albert Einstein lays the foundation for the invention of the laser in groundbreaking Einstein coefficients. 1960. The first lasers, the Ruby laser and Healy laser, are invented. 1961. The Q-switch laser are still the workhorse in many industrial and microelectronics applications, and also the first laser is approved for LASIK eye surgery. What are the fundamental or principles of a laser? Generally, laser works in the form of process that consists of four important processes. They are absorption, second one is spontaneous emission, third one is pumping and population inversion, and the fourth one is the simulated emission of electromagnetic radiation. Now let us discuss about the processes that takes place in the atoms in detail. First one is the absorption. It is well known that an atom consists of different energy states. Let us consider two energy states of an electron. Let us say ground state as Eg and excited state as Ex. When electromagnetic energy falls on an atom in the form of light photon of frequency mu, whereas electromagnetic energy is equal to the difference of Eg minus Ex is equal to h mu. When its energy falls on the electron, it absorbs the energy and jumps from the ground state Eg to excited state Ex. The second one is spontaneous emission. As we already said, electrons jump from ground state to excited state. But the excited electrons that jump to the higher energy state doesn't remain for longer period in that state, and it comes back to its original ground state by losing its energy in the form of photons. The photons don't have any correlation in phase and thus considered as incoherent light. Thus, the release of energy by electrons on their own is known as spontaneous emission. Transition of electrons from one state to another state occurs randomly in time. Spontaneous emission is defined as a process in which the electrons in the excited atoms are released on their own from their higher energy state to the ground state. The third process, the transition electrons, don't stay for a longer time in the excited states. There are electrons of some substances or systems where they remain in excited state for a longer period. Such systems are called active systems or active media. These are generally compounds or mixtures of different elements. When electrons turn into active system, their electronic energy levels are also modified, and thus it acquires some special properties. Now let us discuss them in detail. Now let us consider an atom has three electronic states, E1, E2, and E3 in active medium. Generally, electrons exist in lower state called as ground state, E1. Let us number of electrons in ground state as N1. As we already learned, due to the process of absorption when electromagnetic energy equals to the difference of E3 minus E1 are incident on an atom, electrons jump from state 1 to the excited state 3. Due to the process of spontaneous emission, the excited electron in the E3 state remains for a less period in order of 10 power minus 8 seconds. Usually, most of the electrons loses its energy due to the spontaneous emission and returns from E3 state to E1 state. The number of electrons in this state is said to be as N1. But some of the electrons may lose very less energy, E3 minus E2, and jump to the state E2. The less emitted energy by electrons is called as thermal energy. This energy is absorbed by the medium itself. The transition or jumping of electrons from E3 state to E2 state is called as non-radiative transition or invisible transition. The electrons in this state, E2, remains for a longer period compared to state E1, in the order of 3 times 10 to the power of negative 3 milliseconds. This electronic state is called as metastable state. The number of electrons in this state is said to be as N2. The number of electrons N2 in the state E2 will be increasing rapidly. At some point, number of electrons N2 has more number than the number of electrons N1. That is, N2 is greater than N1. This stage is called as population inversion. The process in which the number of electrons N2 in a higher energy state, called metastable state, of an active medium is increased to a value greater than the number of N1 in the ground state, that is N2 is greater than N1, is called as population inversion. How could we achieve population inversion? Population inversion is achieved by the supply of sufficient and appropriate energy to the active medium from an external source. Thus, the process of achieving population inversion is called as pumping. The last process is induced and stimulated emission. Earlier, we had learned that electrons remain for a longer period in the metastable state, that is 3 times 10 to the power of negative 3 milliseconds. Now, let us assume coherent beam of light energy h mu is equal to E2 minus E1 incident from an external source on the active system. The light energy in the form of photons stimulates electrons in the state N2 to undergo transition to the state N1. The large number of photons of same energy is simultaneously emitted. Thus, the emitted photons have the property called as temporal coherence, and this process is called as induced or stimulated emission. When an active medium is in enclosed state, multiple reflections of emitted light occur, where stimulated emission dominates spontaneous emission. Thus, the incident beam of light gets amplified and the result in output as laser, light amplification stimulated emission of radiation. Now let's go on to the applications of laser in medicine. Lasers are being used in various ways in medicine. First is the bloodless surgery. Second one is liver and lung diseases. The third one is detecting ulcers in the intestines by passing lasers through fiber optic endoscope. And the fourth one is lasers are also used to reattach or detach retina as a treatment of eye diseases.
So how does laser eye surgery actually work? The first step is to separate a thin layer from the front of the cornea. This can be done with either a flat, wide blade or a femtosecond laser that produces millions of tiny plasma bubbles to create a plane beneath the corneal surface. Surgeons then lift the flap to expose the inside of the cornea. Guided by the refractive error and the shape of the cornea, the excimer laser robotically sculpts the exposed corneal bed into the correct shape. This process usually takes less than 30 seconds for each eye. Finally, the flap is closed, and its edges reseal themselves in just a few hours. Because the lasering is done on the eyeball itself, it's described as in situ or on-site. Its complete name is laser in situ keratomylosis, but you probably know it as LASIK. Essentially, this technique carves a patient's contact lens prescription onto their cornea. Like any surgical procedure, LASIK comes with certain risks. Some patients experience slightly blurred vision that can't be corrected by glasses, but the technique is currently about as likely to damage your eyes as wearing daily disposable contact lenses for 1 year. Today, a technique called SMILE enables surgeons to sculpt the cornea through even smaller incisions, further reducing recovery time. And lasers aren't just correcting the 3 types of refractive errors. This technology can also restore aging eyes. In a technique called laser blended vision, surgeons adjust one eye to be slightly better at distance vision and the other to be better at close range vision. The difference between the 2 eyes is small enough that most patients can merge their vision, allowing both eyes to work together at all distances. Advances in laser technology continue to make vision correction surgery more effective and accessible.